Okay, let's do 7b for the geometric description. There is an explanation on this in the solution, but I will explain this using other approach. So if I have tx equals to ax, this is equal to 1, 0, 0, 0, half, minus half, 0 minus half, half, multiplied with xyz. Okay, and this will transform this xyz point into x, half y minus half z, minus half y plus half z. And we see from here, no matter what is your point x, it will remain the same. And the value x here doesn't affect the values of yz after transformation. So what we need to care now is just how this matrix A transform the point yz. Okay, what is this transformation? Okay, so what will this make? Just now I said that we don't need to care about my x, so we can just consider the yz plane. Okay, we can just consider a yz plane. Let's draw yz plane. Okay, and if you remember last time how we construct this matrix, this is actually the transformation of the point 0, 1, 0. This is actually the transformation of the point 0, 0, 1. So if I have a point 0, 1, 0, let's say this here, it will be transformed to the point half minus half. Okay, let's say this is yz plane. Sorry, this is yz. So half minus half, so it is here. Okay, let me transform here. And if I have this point 0, 0, 1, so it is here, it will be transformed to minus half and half, minus half and half, let's say it is here. Okay, it is quite difficult to guess, so you can try to make use of other points. Let's say if it is 0, 0, it will be here. Okay, and you can try other points, and okay, I will not try it, you can try it yourself, and you will see that actually the points that you try after transformation, it will be on this line. Okay, and if you draw a line, it will be perpendicular. Okay, so for example, if I have this point here, after transformation, it will be perpendicular to this line. If I have this point here, after transformation, it will be here, so on and so forth. Okay, but then we need to prove this, right? So how to prove this? To prove this, I just need to show that if I have a random point on the yz plane, okay, and if I project down to this line, let's call this y prime z prime. This y prime z prime will be this, half y minus half z minus half y plus half z. Then you are done, right? So how to find this y prime z prime? We can make use of vectors. Okay, I forgot to mention, this line is actually y equals to minus z. Okay, so what we can do, we can consider, let me use pink color, this vector, okay, and I want to project this vector onto this vector, okay. So it will look like this. Sorry. Okay, and this line, the direction is just 1 minus 1. Okay. One minus 1. Okay, good. So we have y prime z prime is equal to yz, take dot product with 1 1 divide, sorry, 1 minus 1 divide by the length of 1 comma minus 1 square multiply with the vector 1 minus 1, and this is just y minus z. The length of this is square root 2. You square it becomes 2. 1 minus 1. So you will get y over 2 minus z over 2, comma minus y over 2 plus z over 2. And you see that this is exactly the same as this, right? So indeed, the transformation for the yz actually projects the point to the line y equals to minus z. Okay, so overall, this transformation a x will make the x value remain the same, and for the yz, okay, if you have yz, it will project this yz point onto the y equals to minus z. Okay, I think it is enough. Hope it is clear.